Okay, so at 5D they ask, what will happen if we remove some of the oxygen? So there's the oxygen, and they ask, what will happen if we remove some of that? Okay, so we take it away. Declan, what did you say? What will happen?
I left that question off. Because I was looking at the question.
Let's see. So there's equilibrium, and then they say that is removed, taken away. So some of your reactants becomes lighter. Where will the equilibrium shift to? And that's what you did. Shift to the right. Oh, no, wag. Sorry. No. I'm on the wrong side. Oxygen. Remove oxygen. It will shift to the left. Sorry, guys, it's to the left. No, it's to the left. Left. Because what did we do? We removed some of the oxygen of the reactants. And it's going to shift to the left. Okay. Then you also had to do question 7. Okay, it's question 7. They say that we have this reaction. Okay. Now, when they give that to you like that, what is 3 things that you check, Antoinette? 3 things that you check.
3 things that you check.
Chabu?
Yes,
You check the phases. So you see this one is a solid. Careful. What else? Mama? Okay, and what is it? Endo. The forward reaction is endothermic. And what's the last thing that you check? It is balanced. You check, I'm going to tell you check the mole ratio. Now, careful. When you check the mole ratio, why would we check that? If we put pressure on. Okay? When you check the mole ratio, you only check it for the gases. The pressure is only applicable to gases. Okay, so not to solids. So then the mole ratio is 1 to 2 when we work with the gases. Okay, then they tell you there that initially you had 24 grams of that, and you had 3 moles of that, in a container that's the volume is 10 cubic decimeters. At equilibrium, you have 2 moles of that. Now they want the Kc value. Okay, now this is a good exam question. Okay, because there's a bit of a trick with the carbon solid. And they give you, now this is very important that you understand this. They give you information at the beginning and they give you information at the end. If they do that, beginning information and end information, then you must do the mole table. The homework that you had for yesterday, they didn't ask that. They only gave the end stuff. Then you don't have to do the mole table. But if they give you information at the beginning and information at the end, then you do mole table. Okay, so we have the mole ratio, beginning, change, end, and then we have the concentration, that is mole divided by volume. The mole ratio here is 1 to 1, gives me 2, and I'm going to highlight that a certain color or a different color so that I know that is my recipe. I know at the beginning I have 0 of that. Okay, and then they say I start with 3 moles of this. Can I fill into one of that 24 grams in there? No, I must convert it to moles first. Mole is mass over molar mass. Remember to show the formula, you get a mark for the formula. The molar mass of carbon is 12, so that gives you 2. So that 2 is that 2 there. Right, and at the end we have 2 moles. Okay, so if I see or check, I see I had 0 to start with here, and I had 2 at the end, so that means I had to add 2. The mole ratio is 2 to 1. So if I added 2 there, I must subtract 1 here and subtract 1 there. Okay, so here I have left over 1, 2, and there's a 2. Then I must go calculate the concentration. That is the mole divided by the volume. Bookie, do I have to calculate the concentration of carbon? Say again?
No.
Why not? It's a solid, and a solid's concentration can't change. So you never calculate that one, okay, if it's a solid. Right, the other ones we're going to say 2 divided by 10. So there, so you get 0.2 and 0.2. Okay, now we calculate the Kc value, and that is the concentration of the products over the concentration of the reactants. Liakwe, are you happy with my formula? Yes, no, why not? Something missing? Square. And do I not have to put in the carbon there at the bottom? Why not? Solid. Okay, now remember, when you put in your values, you lose the square brackets. Otherwise, it's wrong. And Princess, without a calculator, what is the answer? Yes, nee, wag, wow, kyk. Does it have a unit? No, no unit. Okay, then at question 7b, so that was 7a. And remember that this question can count 1, 2, 3, 4, 5, 6. I think this one would have counted 7 marks. Okay, there was questions that went up to 9 marks. Okay, so this one is 7 marks. Do not stop. What do you get a mark for here? You get a mark for writing that formula and using it. You get a mark for actually doing it. You get a mark for the mole ratio. That it would be a mark with your mistake. This would be a mark with your mistake. You get a mark for that. You get a mark for that with your mistake, and get a mark for that one and this one. 1, 2, 3, 4, 5, 6, 7. Yes. Okay. So even if you didn't know what to do, but you wrote down the formula and you used it, you used the mole ratio, even somewhere you made a mistake, you used that, you did that, you can still get 5 out of 7, even if your answer is completely wrong. Okay, so please don't stop. Okay, then question 7b, they ask, what do you derive from the term or the statement this? We already said that the forward reaction okay. And then question C, they ask, how can you increase the Kc value? What is the one thing that increases the Kc value? Temperature. Okay, but what specifically? What are we going to do with the temperature? Are we going to increase the temperature or decrease the temperature? Okay, let's think about it again. The forward reaction is endothermic. If we make it colder, what will the reaction want to do? Heat it up by favoring the exothermic. So it can't be that. Okay, so we need to heat it up. Then the reaction wants to make it colder by doing what? Favoring the endothermic. So how can we increase the Kc value? By increasing the temperature. Okay, then you have to do question 9. Okay, so at question 9, they say there you have this reaction that you've seen now a couple of times. We check for a few things. Okay, we check they're both gaseous sharp and we check the mole ratio 1 to 2. And they didn't say if it's an endo or exothermic reaction. Okay, now what they do say is at 300 kelvins, the Kc value is 1.6 times 10 to the power negative 1. And at 600 Kelvin, the Kc is 1.6 times 10 to the power of 4. Yes. Okay, so just to rewrite that a bit differently, that is the same as saying 0.16, and this is the same as saying 1,000, 16,000. Okay? Yeah. Okay. Now they ask you at 9a, write the equation for the equilibrium constant. So that will be the Kc is the concentration of nitrogen dioxide over the concentration of dinitrogen tetroxide, and there must be a square there. Okay. B, they ask you, calculate the concentration of nitrogen dioxide in the container at 300 Kelvin if the concentration of dinitrogen tetroxide is that. Okay, so I'm just going to use this formula here. They say at 300 Kelvin, so here I have 0.16 there. We must calculate this concentration, and dinitrogen tetroxide, they said, is 10 to the power of negative 2. Next time I'm going to check homework a lot again because I see that you guys are going to do it fully, completely. So be warned ahead of time. Someone doing it? Are you checking me? Do you agree?
Yes.
Thank you, Mama. 0.04? No, yeah? Or 4 times 10 to the power negative 2. And does it have a unit? Yes. What did we calculate? We calculate the concentration of nitrogen dioxide. And that does have a unit. It's moles per decimeters cubed. Okay. And then at question C, they ask you, is the above reaction exo or endothermic? Give a reason for your answer. And this will count 4 marks. 4 marks. Okay. So this is where they will actually, in the test or exam, they'll ask, use Le Chatelier's principle to prove whether it's endo or exothermic. Okay. So this is where we're going to start. And we did a question like this in your notes. Similar. Okay. Let's start with the obvious. What did we do from there to there? Increase the temperature, right? And then what happened to the Kc? It increased. Okay? If the Kc increases, what does it mean for the forward reaction? Is it favored or is the reverse favored? The forward is favored because the Kc is the product over the reactants. If it's a bigger value, it means there's more products made. Okay, so that's our first 2 bullet points. We're going to say when the temperature was increased from 300 Kelvin to 600 Kelvin, the Kc value also increased. That's what you see. That was stating the obvious. Thus, the forward reaction is favored. Make sure you understand what you're writing down. You agree with that statement. Ask if you don't agree or don't understand. Yes. Say again? With the? No. Because the weather is not a closed system. Alright, so let's just check here. So if the temperature increases, we saw the Kc value increase, meaning the forward was favored. Now, what is that golden sentence that we say? According to Le Chatelier's principle. What excuse?
If I said the temperature has been increased from 300 degrees to 600 degrees.
Not degrees Kelvin, but yes.
Then an increase in temperature favors endothermic because the forward reaction is
No, you're going to get 3 out of the 4 marks because you didn't say an increase in temperature. You said favored the. Okay, but you didn't say forward. You said it will favor the endothermic reaction, but you didn't say.
No, I said does the forward reaction.
Yeah, but you said it's like saying. Okay, let me complete this and then I'll give you. Let me just think of analysis. Okay, so and you must say the word according to Le Chatelier's principle. Okay, according to Le Chatelier's principle, an increase in temperature will favor the endothermic reaction. Okay, so let's see. You'll see always after the third bullet point, I take out my highlighter. Then we said the forward will be favored. You missed this bullet point, Jabu. This is the bullet point that you're missing. The forward will be favored, and we said we favor the endothermic. Okay? So we have forward favored, favor endothermic. So what's the same word in both? Favored. So if you scratch that out, you get the forward is endothermic. Read your sentence again, Jobber. You said an increase in temperature will favor the forward reaction. No, you said? Okay, and then? Thus the forward is endothermic. So what you are basically saying is, you're saying, I might catch myself on this one, but you can say grade 12s are lazy. Thus all learners are lazy. You see, you're like, something's missing. You need to prove that all learners are lazy. You need to prove more than 12, grade 12s. You see?
If they gave us that it is endothermic, we would have said that.
Yes. Okay, so you have to prove one more bit. Okay, then question D, the asker there. What effect will the increase in pressure and the temperature remains constant have on the system? Okay, have on, and then they ask the following. What will increase in pressure? So an increase in pressure means a decrease in volume. Okay, and then at question I, they ask, what will that have on the equilibrium position? If we look there, increase in pressure, meaning it goes to the smaller mole. So the equilibrium will shift to the left. Equilibrium shifts to the left. And then they ask at question 2, what will it have on the equilibrium constant? What effect will it have there? No effect. Because only temperature changes the Kc. Okay, then question 10, they give us this equation. What is this equation's name? Haber process. All right. Then you check for 3 things. You check the phases, gas, 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 sharp. You check the mole ratio is 4:2. And you should know that the forward reaction is exothermic. 1, 3, 4 to 2. There, 1 plus 3 gives you 4 to 2. Okay. Okay. They ask there, question 10a, what influence? No. They ask, what is the influence on the nitrogen, the concentration of nitrogen, if the equilibrium moves to the right? So they said something happened, we don't know what, something happened, that the equilibrium shifts to the right. What would happen to the concentration of that? If the equilibrium shifts to the right, what's going to happen with the nitrogen? Yeah. No, is it going to increase or decrease? Decrease. Why? Because if it shifts to the right, it means that these two things had to react with one another to produce more of that. So that is used up. So the concentration of nitrogen, decreases. The concentration of nitrogen decreases. At question B, they asked, what happened to the number of gas molecules if the reaction is forced to the right? So again, something happened, we don't know what. The reaction is forced to the right, and they want to know what happens to the number of gas molecules. If the reaction is forced to the right, what will happen to the number of gas molecules? Decrease, right? It will become less. 2 is less than 4. Okay, now they ask, is the reaction to the right exo or endothermic? We already know from studying that it is exothermic. Okay, then at question D, they ask, how will the equilibrium position be influenced? Okay, by increasing the concentration of nitrogen dioxide. See, if we increase this concentration, what's going to happen? It's going to shift to the right. Number 2, they ask, if we remove ammonia, okay, that is the same as saying we decrease the concentration of ammonia. So ammonia, we make less, where is the equilibrium going to shift to? To the right. Number 3, they say, if we heat, so we increase the temperature. What will an increase in temperature do? Favor the endothermic reaction. Which is the forward or the reverse reaction? Endo. If we increase the temperature, it's going to favor the endo. So it's going to go to the left. Number 4, they ask, what happens if you increase the pressure on the system? Increase in pressure means we decrease the volume. Decrease the volume means it favors the one with the lower moles. So is it going to go to the right or the left? The right. Question 5. What happens if we increase the concentration of hydrogen? Increase the concentration of hydrogen. What's going to happen? Go to the right. Number 6. They ask, what happens if we add a catalyst? Nothing. No effect on the equilibrium. No effect. And then lastly, they ask if we decrease the concentration of hydrogen gas. So there's a hydrogen. If we decrease it, it's going to go to the left. Okay. Now I quickly want to ask, I know that is your only homework, but I quickly want to ask something. If you look at this reaction, this is actually question 6, by the way. I'm not going to do the whole 6. Okay. I want to know, give me 2 things, so this is 6b. Give me 2 things that will not change the equilibrium position. 2 things that will not change the equilibrium position in this question. Why do you say pressure?
They both have the same moles.
If you look there, it's 2 moles versus 2 moles. So if you increase the pressure, which side is favored? We don't know, because it's the same mole. And
And the user is asking how does H2O exist?
if it's heated, if it's warm. If it's warm. This reaction takes place at like 200 degrees Celsius. And a catalyst. So the 2 things is a catalyst and a change in pressure. Okay. Then in grade 12, I asked you to bring this booklet, right? Yes, I did. I put it up as well, and then Tulwana said she already has one. Okay. I want you to please open this booklet on page 74. Page 74. Yes. Or you know what? Oh no, mine Afrikaans one is. No, wait. Yeah, no, sorry. $74. 74. Okay. Yeah, quick. 74. Immediately. Wait. What, did they chase you away?
No, one has a book.
Mama has a book.
Yeah, but then they already made some. Oh, I'll just take a photo.
Okay, but I will take a picture, but I just want to show you something. All right, quickly, I want to speak about it. Okay, so on page 74. Are you going to sit now there?
Oh, yeah, put a book there.
Yeah, okay. All right, on page 74, 75, and 76, 77, you can see there they give you graphs. Okay, and they are going to give a lot of graphs in this in these questions. What I want you to look at on page 74, there at the bottom, there they give you reaction rate versus time. Okay, you see it starts with dotted lines and then it goes together, together, together. Okay, so there it gets together, there it reaches equilibrium. And then there's a big spike going up for both of them. So you can see the forward and reverse reaction has an increase in reaction rate. Means they both happens faster. What can do that? What can make them both go faster? A catalyst. Okay, so that's how we read it there. What I want you to see on the next page. Okay, there at the top on the left, it says reaction rate versus time. Okay, reaction rate versus time. And you can see it happens, you know, get together, here it reaches equilibrium. And then all of a sudden, there's a big spike for both of them. Okay, but the one has a bigger spike than the other one. Okay, now why would that happen if it's reaction rate? What makes both of them go faster? There's a few things. An increase in concentration, increase in temperature, finer powder, different
Surface areas.
not surface area and nature of the particles. Now what's the other thing? A catalyst. Okay, that is 5 things that can make them both go up. But we can see here, this is in a reaction. In this reaction, can we all of a sudden change the nature of the particle? No. Can we all of a sudden go from granules to powder? No. So those 2 things are. So we're left with concentration, temperature, and catalyst. Now what will a catalyst do? It will make them both go up equally the same amount, like the first graph. That didn't happen. So it's not a catalyst. So it's either an increase in temperature or an increase in concentration. Okay. Now this is where you have to see. Okay. What am I going to do? I see here that they both go up the same amount, and then you've seen this reaction before. They give us this reaction is exothermic. So it means an increase in temperature will favor which one? The endothermic reaction. The reverse reaction will be favored, and the reverse reaction is the dotted line. Which one is favored more? The reverse reaction is favored more. You see that? And then they get together and they form a new equilibrium. Okay, so there's that graph. The other graph next to it is just the inverse of it. If you decrease the temperature, you see they both go down. Okay. Say again? No, you are going to get graphs and they're going to ask you to. They can ask you a simple graph like the first graph to draw that, but they won't ask a complicated one like this. Okay. Right, then what I want you to see there at the bottom as well. Let's see, guys. Oh, what did I just do? Where? Okay, there at the bottom, you see it's the same reaction, but now the graph changes. Now it is concentration versus time, not rate versus time. Okay, so you can see there the concentration of the products is little and the reactants is a lot. Then at a certain point they reach equilibrium. They do not have to be the same amount, okay, because their mole ratios differ. So they don't have to be the same amount at equilibrium. Just when they get flat, it reaches equilibrium. Then we see there's a big spike, a big something happen. We get a lot of reagents and the products become less. Okay, how can that happen? What can be done? Well, if the products becomes more, reactants becomes more, then we could have either changed the temperature or changed the concentration. Now, if we change the concentration, this graph would be like a sharp up, not a gradual up. Okay, it will be like a straight line up because in 1 second we added all of them. So if it's a gradual up like that, then you know it's a change in temperature. Okay, so if you look on the next few pages, they explain that with all of the type of reactions. Change in concentration, change in concentration, change in pressure. I think that's what they give you there. Okay, so they can ask you to interpret the graphs, and that's what I want to do today in a question. Okay, so I want us to go. I wanted to do 2 questions. I wanted to do question 12 and question 9. That's the 2 that I wanted to do. Okay. 12 and 9. So let's start at question 12. This is, in my opinion, the more difficult one. Okay, and then we take it from there. All right. So at question 12, are you writing this down? While you're writing this down, I just want to remind you of the extra classes. Nee? That I sent on the group. Yes? I spoke about it yesterday, I think. There. The extra classes is you write on the 15th, you write paper 1. So on the 13th, in the afternoon, after you've written life sciences, we're going to do the mock test, the mock exam, together. So you're not going to do exam, doesn't count for marks, we're going to do it together. Go through the question paper. I received it yesterday, it's 2 hours, 100 marks, and we'll do it together. Alright? Then on the 14th, you don't write at all. Nobody writes. Of the grade 12s. The 14th in the morning, we're going to do an extra class where I'm going to revise topics that we struggled with in the mock test. And I'm going to revise electricity because we haven't revised that yet. Okay, so that's going to happen in the morning. Then you are free if you want to sit the rest of the day in my class and work through question papers and I'll assist you. You're more than welcome to do that. But I know some of you want to go to other extra classes as well. So then you'll have the rest of the day to do that. The 15th, you write exam. Then the 16th is the youth day where you said you're going to go to Kwakwa. But we will have also a mock exam that morning. Okay, for paper 2. Also, again, not for marks. We're going to go through the question paper. And if there's time left, we are going to revise some topics that you struggled with. All right. So, I am not going to call you if you do not pitch. But I am going to call you the next term and tell your parents you didn't pitch. Especially if I look at your marks and I see, why did you get 40%? Oh, you didn't come to extra class. Ma'am, sir, I did all I could. They didn't. Huh? No, it's not good. All right. So we are at question 12, and this is on page 83. And I just want to put in my graph there. Okay, well, as you look at the graph, you always check what is on the y-axis because you can get different graphs. You can either get the number of, meaning the concentration. Okay, it's not necessarily concentration is the number of, but particles, or you can get rate. Okay, then they say there, it represents a hypothetical reaction in equilibrium container and after 2 minutes at room temperature, it reaches equilibrium. The letters X, Y, Z represents the number of moles in a balanced equation. Okay, so if we look there, we have X, A plus Y, B gives you Z, C. Now, I checked all their phase subscripts. They're all aqueous, 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 so chop. They can stay there. Okay, let's just see here in the graph. You can see here after 2 minutes, the lines become horizontal completely, so that's where it reaches equilibrium, but that happens again here at around about 6 minutes again. So something changed here at 4 minutes, and then at 6 minutes it reaches equilibrium again. Okay, now the graph shows the change in the number of moles of reactants and products versus time during the reaction. Now they ask, define the term dynamic equilibrium. What is dynamic equilibrium again? Now remember, in this booklet, they give you all the definitions as well. So if you page back in the booklet to page 70, there it says chemical equilibrium, dynamic equilibrium. Okay, so chemical dynamic, they say it's the same thing. When the rate of the forward reaction is equal to the rate of the reverse reaction. So that is the rate of the forward is equal to the rate of the reverse reaction. Okay, so it's an easy definition to study. Then they ask, use the information in the graph to write down the values of X, Y, and Z. Okay, so even though it only counts 3 marks, we must do a mole table. Okay, because we have that, that, and that. We don't know the mole ratio. That is actually what we want to get at the end. Okay, but what we do know is the beginning and the end values. We have that. At the beginning, A was 16. Okay, so at the beginning, A was 16. And at the end, A is 8. See that? At the beginning, B was 8, and at the end it is 4. And at the beginning, C was 0, and at the end it is 12. So that was the difficult part in this question, is knowing you had to do this. Okay, but I already told you at the beginning of this lesson that if they give you, information at the beginning and information at the end, you must do a mole table. So they didn't just write it in words, they gave it to us in a graph. So information at the beginning, information at the end, mole table. Okay, now the difference here is plus 12. This is negative 4. This is negative 8. So is the mole ratio 8 to 4 to 12? You must always do it in the simplest ratio. So we can divide all of them by 4. So then the mole ratio is 2 to 1 to 3. So from there to there, we divide it by 4. So now we can write down at 12.2.1, x value is 2, y value is 1, and the z value is 3. Okay, then they ask you question 12.3. Calculate the equilibrium constant for this hypothetical reaction at room temperature if the volume of the closed container is 3 decimals. So the volume is 3 cubic decimeters. Heaven marks. Okay, we already have the mole ratio. We already have the mole at the end. What's the next thing we need? The concentration at the end. Concentration is mole over volume. We already checked at the beginning. They were all, if you look on the question paper, they were all aqueous, aqueous, aqueous. So they can all be in your table. Okay, then we have the mole at the end. We just need to divide it by the volume. Okay, so that is 8 divided by 3, 2.67. And that gives you 1.333, and this gives you 4, I think. Okay, so you'll see, if you go through all question papers and whatever, that they do this all separately on the side. But you get marks for writing down the formula and then having used the formula. So here you do not have to show divide by 3, divide by 3, divide by 3. If you just do it, you get the marks. But you can show divide by 3, divide by 3, but you don't have to. Right, what will our equilibrium constant equation look like, Bokkie? Look at your equation there, your reaction. It will be what? Yeah? It's square bracket. Yeah, Jabu? ZC. Just C. But where does the Z go? It's to the power of Z. And what is Z? We just got Z to be 3. So it's to the power of 3. Okay. Then the concentration of A, and we 2, and then B. Okay. Then we fill in our concentrations. That's 4 to the power of 3. Declan, remember when you fill in your values, you drop the square brackets. If you're going to do that in the exams, you will be the reason that I swear. What say, Mama? What did you say? Yes, you better not. Does it have a unit, the Kc value? No. Okay. Then they say, at time 4 minutes. Okay, so where's 4 minutes? There's 4 minutes. At time 4 minutes, the temperature of the system was increased to 60 degrees Celsius. So they made it warmer. Okay. Is the reverse reaction, can you see that it's in capital letters? Is the reverse reaction exo-endothermic? Explain how you write out your answer. 3 marks. Okay. Wait. So we are going to start at question 12.4. We're going to start with writing the obvious thing first. What happened when they increased the temperature? Was the forward or the reversed favored? We can see there, this is the reverse reaction. It was definitely not favored. This is the forward reaction, and it was both favored. Can you see that? Okay, so we start with the obvious, we say an increase in temperature favors the forward reaction. Okay, and you can even go further to say, why did we see that? We saw that the number of products increased. That's how we saw it. Okay, then according to Le Chatelier's principle, I'm going to abbreviate it now because I think the bell's going to ring. According to Le Chatelier's principle, an increase in temperature favors the endothermic reaction. Okay, so what do we have? We have the forward was favored, and we have favors the endo. The forward was favored, favors the endo, so it favors both out, so it means the forward reaction is endothermic. But what was the question? What is the reverse reaction? So remember that we're going to say, thus the forward is endo and reverse is exothermic. Alright, please go to past papers of this one. Alright, that's very important. Good luck with